Horizontal heat. For thousands of years, we had heated homes with indoor fireplaces using chimneys. Chimneys are mentioned in the Bible. These homes, one small and one large, are at the Lexington County, South Carolina Museum. Yurts use chimneys. The technology has been basically unchanged for millennia. On the left, we have an English building from the 16th century. On the right is a log cabin in Guildwood Park in Scarborough, Toronto. In the next few minutes, you'll see two new ideas that will greatly improve the efficiency and lower the cost of home heating, especially with fireplaces. They also enable radiant solar heat to be moved from outside, where it's currently unused and wasted, to inside, where it's needed. They may be the first significant advances in home heating in thousands of years of history. They may be easily adapted to improve the efficiency and lower the cost of heating your own home. I call them horizontal heat. The main limitation with indoor fireplaces and space heaters is that most of the heat goes straight up, not horizontally. This may be mitigated with fans, but these have limited horizontal range. For fireplaces, 80 to 90% of the heat goes straight up the chimney without warming anything or anyone except the environment. To say that this is a significant waste of resources while warming the planet is a gross understatement. For an analogy, what if a dishonest gas station owner rigged his pumps so that the pump showed 10 gallons pumped, but only 1 or 2 gallons actually went into the customer's car? That's outrageous, you say. Deal with it. We've been doing the same thing with fireplaces for thousands of years. The well-known limitations of fireplaces were mitigated in part by building and fueling multiple fireplaces at considerable expense. Horizontal heat captures solar radiation, wasted heat from chimneys and fireplaces, and electrical resistance heating elements to warm homes. It moves the heat generally horizontally, not vertically. There are two ways to do this. The first one uses simple fluid pressure. It's called heat transfer device. The second one I named dynamic fluid leveling, or DFL. They both involve heating and moving a liquid, not air. It's hard to move air horizontally, but much easier to move a liquid. They are both patented. Simply put, moving heat with air is hard. Moving heat with water is easy. Part the first, fluid pressure, heat transfer device. This simple closed circuit is the heart of the invention. It is a conduit filled with a working fluid with two valves, a one-way check valve and a pressure relief valve. A portion of the conduit is heated by the sun. The working fluid may be a liquid or a combination of liquid and gas or vapor. The heated working fluid is trapped between the two valves. As it heats, it expands, or tries to. The pressure between the two valves increases, and the pressure relief valve opens. Think of it like this: sealed vessels on a hot plate. Only kidding. Do not try this. The hot, pressurized fluid is propelled through the conduit. The pressure and temperature of the fluid between the two valves both drop. It gives up the heat as it passes through a living space. The process repeats in an endless loop. It is absorbing radiant solar heat and pumping it through a conduit at fuel cost zero. It is entirely solar powered. No user-supplied energy or fuel are needed. It is transferring radiant solar heat, previously unused, to the living space at fuel cost zero. This is especially effective using isopentane, a component of crude oil, which vaporizes or boils at only 82 degrees Fahrenheit. This increases the pressure and the turns. It absorbs heat in the sun and then disperses that heat indoors. Implemented in a house. A coil of tubing is placed on or wrapped around a flat black plate. Both absorb solar radiation. Capturing solar radiation. The heated working fluid warms either space heaters, baseboard heaters, radiant heat flooring, or a crawl space. The flat plate may carry yard art with the coils on the underside out of sight. But it only works when the sun is shining. Maybe. Consider that I measured a temperature of 158 degrees Fahrenheit on a front door painted stylish black in full sun of a house in mid-February with ambient temperatures in the mid-40s Fahrenheit. The heat pump was running. We need to get some of the free 158-degree heat from the front door into the house, reducing the load on the heat pump. This invention does that at fuel cost zero. So, even if it worked only when the sun was shining, if I could install it for $250 and save you $2.50 in energy costs every day that the sun shines, you would recover your investment in short order. And as you will soon see, it can work on cloudy days and at night. This is a hot plate, an electrical resistance heating element, outside the conduit. Using a digital thermometer, I measured the temperature of a Walmart hot plate, which costs $11, at 814 degrees Fahrenheit. This photo shows only 758 degrees Fahrenheit. Here is the electrical resistance heating element outside the conduit and living space, maybe in a garage or attic in an insulated housing. The heater can easily reach more than 800 degrees Fahrenheit at low energy costs. The electrical resistance heating element may be inside the conduit. An electrical heating element in contact with water might seem dangerous, but this is what electric water heaters and steam irons do. For a chimney, the conduit loop is coiled around the flue inside the chimney. The conduit is filled with oil and thermally insulated, think of pool noodles, across the ceiling and down the wall to underfloor. It captures some of the heat going up and out of the chimney, currently completely wasted. Capturing fireplace heat. Placing the fireplace outside the house increases the capture of heat with a flat plate and housing and decreases indoor smoke, irritants, dehumidification, risk of fire, fire insurance, etc. It also keeps fuel and ash out of the house. It improves the performance and efficiency of a wood-burning stove. This stove is hot to touch, but how much heat gets to the sofa? Very little. It improves the performance and efficiency of a wood-burning stove by capturing waste heat going up the chimney and spreading it over a wider area. Here, instead of one heater wasting heat in a corner, it warms two additional space heaters closer to the sofa. integrated into a building's siding. On a cool fall day in South Carolina, the temperature of the dark blue sign was close to the 158 degrees I measured on the black door mentioned above. This figure from the allowed patent shows conduit integrated into the building siding. In the summer, it can bury waste heat on the siding underground. In the winter, the bottom portion of the conduit may be fluid-filled space heaters, baseboard heaters, radiant floor heating, or simply warming a crawl space where the heat rises into the floors by thermal convection and conduction. Cooling the building. In the summer, waste heat is buried. This prevents heat from intruding into the building envelope or the living space. Warming the building. In the winter, the heat is moved to radiant floor heating, space heaters, or to the crawl space, where it rises to the living space above, reducing the load on the heating system. Fuel and energy costs are both zero. Part the second, DFL, Dynamic Fluid Leveling. This is a composite of 4 diagrams. In the upper left-hand corner, we see Aristotle's statement that water seeks its own level. Any liquid added to that system, whether at A or B, raises the level on both sides of the conduit. In the upper right, we see that if water is pumped from A to B, all of the water moves, carrying its temperature with it. In the lower left, we see that this works regardless of either the length or the configuration of the conduit. And in the lower right, we see that this works because it can't not work. If you look at that A and B in the upper right-hand corner, they cannot be at different levels. This is the basis for DFL, dynamic fluid leveling. It's kind of elegant in its simplicity. The conduit may be asymmetric. A small weatherproof housing, like a plastic box, keeps the working fluid from evaporating to the atmosphere. The working fluid never needs replenishment. Capturing fireplace heat. This is very similar to what was shown above. Placing the fireplace and chimney outside the house with a flat plate and housing increases heat capture and decreases smoke, irritants, dehumidification, risk of fire, fire insurance, and it facilitates adding fuel and removing ash. Capturing solar radiation, this is very much like the one shown previously. It will also work with the solar absorbing plate disguised as yard art, the outdoor fireplace, and the chimney mentioned above. This will also work with the electrical resistance heating element mentioned above. Also, similar to the above, DFL, dynamic fluid leveling, uses an electrical resistance heating element to heat water within the conduit, which is distributed generally horizontally throughout the living space at fuel cost zero. This is horizontal heat. These are two ways to move heat, generally horizontally. They move heated water, which is easy, not air, which is hard. For more information, please contact John Saavedra. My email address is my last name, Saavedra, at mindspring.com. More ideas at lookforthepower.com. Thank you.